We may have infinite numbers, but lucky for you guys, we do not have that many rules. That would create even more chaos than resolving it, right? We have more good news as well. After our last lesson, we only have 3 more theorems to go regarding the modulus of complex numbers. So, let's take a look at our 5th theorem. These theorems may start to look very complex, but trust me, they are going to be a piece of cake. Let Z1 and Z2 be these complex numbers, such that Z2 is not 0. Is anything divided by 0 is what? That's right, undefined. Now, let it divide Z1. Notice something odd? Yes, the imaginary number in the denominator. We don't like it because we know it complicates our calculations. What to do then? Well, recall a fact we have already learned. A complex number multiplied by its conjugate results in a real number without any iota. Hence, all we have to do is multiply and divide the conjugate of denominator in order to get rid of the iota in the denominator. Pretty straightforward. Now, proceed with the multiplication as usual and group the imaginary and real parts with each other. This will make it easier for you to obtain the conjugate. We got the left hand side. Now, will it be the same as dividing the individual conjugates, you may ask? Well, let's find out. Here are the conjugates of Z1 and Z2 in division. And we'll use the conjugate of the denominator once again to simplify the expression. With the help of some little math, which is a piece of cake for you guys, we'll work out the answer. Compare it with the left hand side. And bravo, they are the same. So we know that the theorem has been proven. Great job, guys. Let's move on to the 6th theorem. In simple terms, it says the modulus of the product of Z1 and Z2 is the same as the product of their moduli. Wow, that's a mouthful, like a mathematical tongue twister. Let's see if we can prove it mathematically. If Z1 and Z2 are the same complex numbers again, then their modulus will look like this, correct? Find their product as per the requirement of right hand side and hold this result for a while. Now, take the left hand side and put the numbers in multiplication. Since you guys are experts at multiplying complex numbers now, we will skip to the final form of the product. Observe how we have real and imaginary parts again, forming a new complex number. Recall the formula for the modulus and simply substitute the values. You can try to expand the quadratic expressions on your own, but we'll take a shortcut to get this expression, which we will simplify a little to get this. Looks familiar, right friends? Our tongue twister was right then. Modulus of the product is the same as the product of the moduli. And that's it for this lesson, folks. But hey, how about an example in the end? By just looking at the Z bars, we know we need some conjugates. So, bring the given values of Z1 and Z3 in the spotlight and find their conjugates. Now, plug this product and the value of Z2 into the fraction as given in the question. You already know how to multiply two complex numbers using the formula. So, let's skip to the final answer. But wait, we have an imaginary number in the denominator. What will we do? We will remove it using the same technique of conjugates. And this is our solution after a little math in terms of a plus bi as asked. Alright, now join me in the next lesson for one last theorem. In the meanwhile, I'm thinking to leave you guys with a fun tongue twister to work with. See if you can say this fast.